In this video, we are going to do a little bit more with rational graphs by looking at a few more examples. So we're going to start with a few reminders about finding asymptotes. And then also, as we do some of the other things, the actual graphs, we'll look at finding the x and y intercepts as well. So just a little review about asymptotes. The vertical asymptote, you're going to set the denominator equal to 0. That'll help find the vertical asymptotes. To find the horizontal asymptote, it's based on the degree of the exponents on the top and the bottom. If the top exponent is less than the bottom exponent, then your asymptote is going to be y equals 0. If your top exponent is equal to the degree on the bottom, your asymptote is y equals the fraction of leading coefficients. Okay, fraction of leading coefficients. If your top exponent is greater than the bottom exponent, then there is no horizontal asymptote. However, when the top exponent is greater than the bottom exponent, if the top exponent is 1 greater than the bottom exponent, then what that means is that we are going to use long division to find the slant asymptote. Okay. So now let's do some examples. So the first one we're going to look at is we are going to look at graphing f of x equals 2x minus 1 over x. So how do we find the y-intercept? I want to remind you really quickly, to find the x and the y-intercepts, in order to find the y-intercept, that means you put in a 0 for x. So if we put 0 in for x to find the y-intercept, we're going to get 2 times 0 minus 1 over 0. But we can't divide by 0. So what does that mean? That means there is no y-intercept. And that's perfectly fine. So right now I want to write NA because there is no y-intercept. Now how do we find the x-intercept? Well, the x-intercept means that you put in a 0 for y. Or in other terms, we just set the equation equal to 0. So 2x minus 1 over x is equal to 0. I'm now going to put 0 over 1. I'm going to cross multiply. That gets us 2x minus 1 is equal to 0. And now we solve that for x. So add the 1, divide by 2, and we get x is 1/2. So our x-intercept is at 1/2 comma 0. So x-intercept is at positive 1/2. So that means I'm going to go over to the graph, and at positive 1/2, I'm going to put a point right in there at positive 1/2. Okay, vertical asymptotes. And just a reminder, vertical asymptotes, your graph can never cross. We're going to set our denominator equal to 0. Which means in this case our denominator is just x, so that means x equals 0 is our vertical asymptote. Now the other thing, this leads directly to domain. Because we have a vertical asymptote at x equals 0, that means for domain, x cannot be 0. So that means our domain is everything but 0. So the domain is negative infinity to 0. Union 0 to infinity. Everything except for that vertical asymptote. Okay, now we're going to look at the horizontal asymptote. Well, to find the horizontal asymptote, we need to compare the exponents on the top and the bottom. So our degree or our exponent on the top is 1. So the numerator has an exponent of 1. The denominator also has an exponent of 1. Since the numerator is equal to the denominator, that means we're going to do the fraction of leading coefficients. So with the equation 2x minus 1 over x, that means our fraction of leading coefficients is 2 over 1. There's an imaginary 1 there. So our horizontal asymptote is at y equals 2. So at positive 2, I'm going to go through and draw in the horizontal asymptote that goes across. So now, slant asymptote, we don't have a slant asymptote in this case because we have a horizontal asymptote. If you have a horizontal asymptote, you do not have a slant asymptote. If you have no horizontal asymptote, you need to check for a slant asymptote. Well, now we're going to find some additional points because we need to kind of see what's going on. We're going to do this compared to our asymptote and then also compared to our whatever points we have. So the first thing I want to do is I want to just look at, let's say, f of negative 1. And I want to figure out if x is negative 1, what's the value? So we're going to put this into the equation. 2 times negative 1 minus 1 over negative 1, which gets me negative 2 minus 1 over negative 1, which is negative 3 over negative 1, which gets us positive 3. So at negative 1, we're up at positive 3. Now here's the thing, knowing that we only have 2 sides, in this case we will not pass our horizontal asymptote, and that means we're on top of the asymptote in general though. So we're going to have the graph that kind of looks like that. It's not going to cross the asymptote at either of the asymptotes. Now let's check another value. Let's look at f of 2 and let's see what's going on with the graph on that side. So f of 2 means we're going to do 2 times 2 minus 1 over positive 2, which gets us 4 minus 1 over 2, which is positive 3 over 2, or 1.5. So 1.5 means that we are getting closer to the asymptote, but we're still below that horizontal asymptote. So on the right, the graph's going to do a curve like that. So now in this case, we are not crossing our horizontal asymptote at all. So that means our range is everything except for the horizontal asymptote. So that means our range is negative infinity to 2, union 2 to infinity. Now we're going to do a second example. All right, so here is our second example. We're going to graph x over x squared minus x minus 2. So y-intercept again. So let's look at this. We're going to have x and y. To find the y-intercept, we're going to put in a 0 for x. If we put in a 0 for x, we're going to get 0 over 0 squared minus 0 minus 2, which gets us 0 over negative 2, which is 0. So that means our y-intercept is at 0, 0. Now, let's find our x-intercepts. To find the x-intercept, what we're going to do is we're going to put in a 0 for y, or we're going to set our equation equal to 0. So x over x squared minus x minus 2 gets us 0. Put 0 over 1 and cross multiply. That gets me x is equal to 0. Well, what that tells me is that the y-intercept was at 0, 0. The x-intercept is also at 0, 0. Okay, so far so good. Vertical asymptote. In order to find the vertical asymptote, we are going to set the denominator equal to 0. So we're going to take x squared minus x minus 2 and set that equal to 0, which means we need to factor. We're looking at two things that multiply to be negative 2 and add to be negative 1. Well, that is negative 2 and positive 1. So x minus 2 and x plus 1. Set both of those equal to 0. We get x is equal to positive 2 and x is equal to negative 1. We are going to have horizontal asymptotes at x equals negative 1 and x equals positive 2. Now again, the horizontal asymptotes we can never cross, but the vertical asymptotes we can never cross, but we can potentially cross a horizontal asymptote. But now let's look at the horizontal asymptote. In order to find the horizontal asymptote, we need to compare the degree of the numerator and the degree of the denominator. Well, the degree of the numerator is 1. The highest exponent is 1. The degree of the denominator is 2 because there's x squared. Since the numerator is less than the denominator, that means automatically our horizontal asymptote is y equals 0. We don't need to calculate anything, but we know right away our graph is y equals 0. Slant asymptote. Again, Because you have a horizontal asymptote, you do not have a slant asymptote. The domain is created exactly from the horizontal the vertical asymptotes. X does not equal -1 and X does not equal +2. So just an easy way to show it, -1, +2, open circles in those locations, but everything else works. So that means our domain is -infinity to -1, union 1 to 2, -1 to 2, union 2 to infinity. That is your domain. We still need to calculate what our range is, but in order to do that, we're going to have to calculate additional points. When we go to calculate additional points, because we have the asymptote at y = 0, that means we really just care if we have places above the asymptote or below the asymptote. So I'm going to think about our equation in factored form. X over x squared minus x minus 2 is x over x minus 2 times x plus 1. So when we check values, so if I want to calculate f of -3, all I really care about is, does that end up being positive or negative? If I put -3 in here, I'm going to get -3 on the top. My denominator, -3 minus 2 gets me -5. And then -3 plus 1 gets me -2, which gives me a negative divided by a positive, which is a negative. So we know that out here at -3, our graph has to be below the asymptote. So the graph is going to look something like this. Now let's do the same thing on the far right. What if I tested f of 4? Well, f of 4 is going to be, we're going to put these values in, we're going to get a positive on top. 4 minus 2 gets us a positive, and then 4 plus 1 gets us a positive, which gets us a positive divided by a positive, which is a positive. So that means out here on the far right, we know that it's positive, and it's not going to cross those asymptotes. But now what happens in the middle? Well, let's test 2 more points. Between our x-intercept at 0 and the y-intercept at 0 and our vertical asymptote, we need to test a point. So I'm going to test -0.5. So -0.5, if I put this into this equation, I'm going to get -0.5 on the top. -0.5 minus 2 gets me a negative. And then -0.5 plus 1 gets me a positive, which makes this a negative divided by a negative, which is a positive. So that means over here in this section, it's going to be positive. And then the next thing is we need to check between our x-intercept and our asymptote on the right. So f of 1 would get me positive over 1 minus 2 is a negative, and 1 plus 1 is a positive, so that gets me a positive divided by negative, which is a negative. So on this side, it's going to be a negative, and that means in the middle, we are crossing the horizontal asymptote. So what does that mean about our complete range? Our range ends up being all real numbers, -infinity, infinity, because we cross over that asymptote in the middle. You will have more practice of this over time.